Okay, pre-cal. The next thing in our notes has to do with symmetry. So we are on page 4, I believe. So this is symmetry. Now, most of you are probably familiar with what symmetry is, but with functions, we have symmetry to determine if a function is called even or odd or neither one. So if we know what kind of symmetry it has, we can determine what kind of function it is, if it's even, if it's odd, or neither one. So here's the thing, symmetry can occur about the x-axis, the y-axis, or the origin. So if you will look at the 3 pictures I've got right down here, it's usually pretty easy to tell visually what kind of symmetry you have, because all you have to do is look at it. So if you will notice this first example right here, this first graph, if you'll notice there's a mirror image on the left and then the right. So these are reflected over the y-axis. So this is y-axis symmetry right here. So what does that mean as far as even and odd go? Well, if you have symmetry about the y-axis, that's an indicator that the function is an even function. So if you have y-axis symmetry, if the graph has physical y-axis symmetry, then the function is referred to as an even function. Now let's look at this second graph. This second graph, we've got this reflected over here and this reflected over here. That's reflected from quadrant 1 and quadrant 3. So that's an indication that we have symmetry over the origin. So remember, the origin is the middle at 0, 0. So when we have origin symmetry, it is said that the function is to be an odd function. So when you're physically looking at it, if it reflects over the origin, then the function is said to be odd. And you know, an easy way to remember, there's an O for origin, there's an O for odd. Great fun. Okay, now look at this third example. You'll notice this piece of the graph reflects down here, and this piece reflects down here. This is known as x-axis symmetry. But when you have x-axis symmetry, the function is neither even or odd. And did you hear what I said there? The function is neither even or odd. That's because it's not a function. So technically, the equation is not even or odd because look, it fails the vertical line test. All right, so we have repeated x values right here and here and here, all over the place. So this is not a function. That's why it is neither even nor is it odd. So that's just an understanding of physical symmetry and what it looks like in a graph. Now we can also determine based on the equation only. So for the function equation, we can only look at the equation and determine if it is even, odd, or neither. And the way we do that, we have rules that we have to follow. And these rules can get a little confusing. So I'm going to do another video with the examples. So the rule for even, odd, or neither, and again, remember, if it's even, that means we've got y-axis symmetry. If it's odd, that means we've got origin symmetry. Okay, so if we have f of negative x equal to f of x, then it is even. What does that mean, Miss Griggs? Well, let's look at this example right here. This ordered pair is 3, 0. This ordered pair is negative 3, 0. So I want you to look at this. I'm going to use a highlighter here. F of x, positive x, right there. F of negative x, that same x is negative right here, okay? And are those equal to each other? Are the y values, see f of negative x equals f of x, are the y values equal? Yes, they are. There you go. Magic. Okay, now the other rule is about it being odd. So f of negative x equals negative f of x, then it's said to be odd. Okay, but can we look at that same issue in this graph? Well, let's look at it. Okay, we've got this ordered pair again. We've got 3, 0, negative 3, 0. All right, so the negative f of x is equal to the f of negative x. So again, this is a positive x right there. This is the negative x right there. Well, is f of negative x equal to negative f of x? Yes, because 0 can't be negative. You with me? Okay, so let's try it on another one. Let's try it on this ordered pair. The drawing is not great, but you can kind of see this here. So this is negative 2, negative 3, and this one up here would be positive 2, positive 3. Okay, so let's look at this again. So I'm going to use my eraser here so I can use this to illustrate this for you. Okay, so positive x right here, this 2, okay, and then negative x, that would be this negative 2 right here. So I want you to think about this. I know you kind of have to wrap your brain around this, but work with me. Okay, so positive f of x, f of negative x, see, is right there. That negative 3, see, because f of negative x, the negative x is right here. So there you have that. This value, the negative 3, should be equal to the negative of the f of x where x is positive. So that would be right here. Well, oops. Well, is negative 3 equal to negative 3? Yes, it is. Magic. So amazing. Okay, so I've got this written out down here. You're welcome to read that. It's pretty much all of the stuff that I just said. And now in the next video, we'll look at examples. Yay.